All right, hello everyone. This next video is going to be the one that corresponds to the time value of money. You should have watched the video or a hyperlink YouTube video about the time value of money from, I think it was McGraw-Hill. And I'm going to supplement this and do a down and dirty video to explain this pretty quickly. Um, when we look at the study of finance, and some people don't realize finance is actually the subtopic or subheading of economics and falls under the category of economics. So um, when we study finance, I like to explain it to people. And again, it doesn't matter if it's personal finance or corporate finance or any other thing. Really, what we're doing is we're using accounting data, metrics from the study of economics, and we're putting those things together uh, in order to, well, and we're adding statistics to that in order to forecast the future, so to speak. So we use accounting data, we use economic metrics and use statistics, and together we apply sort of the forecasting of this. So um, and the study of finance is used to make decisions that create the most value possible. Um, in order to do that, we have to apply a concept so we can better understand the impact of time on money. It used to be said that Albert Einstein was asked one time, "What's the most phenomenal thing that you've seen in the universe?" And his answer was the compounding growth of money, where you don't normally see that anywhere else. Uh, did he ever say that? Nobody's for sure, but he was thought to have said that. So that really looks at the time value of money. And if you've taken an accounting class or an economics class, you may have already touched on this topic. So when we look at the value of money over time, what we need to look at is that it grows exponentially as opposed to growing incrementally. Very often, if I were teaching a normal accounting class, I'd talk about how we'd start off by talking about something called simple interest. And simple interest is the idea that if you go to a bank and you open up a savings account and the bank says that they're going to pay you 1% interest, then at the end of that 1 year, if you deposited $100, you would have an additional dollar in your savings account that the bank paid you. So you'd have $101. Now, in the concept of simple interest, they'd ask you to go ahead and try to figure out in year two what you had. And you would use the base idea of 1% on $100. But in reality, and everywhere else in finance, that's not how it works because we don't use simple interest. So if we use the example of a bank savings account and paying 1% interest, at the end of 1 year, you'd have an additional dollar. But if we had to compute for the next year, the compounding effect is you're not trying to compute the interest on $100 anymore. At the end of the second year, you're trying to compound it based on $101 because the bank already paid you that one additional dollar. So what happens over a time is you have this compounding effect, and we use that to better understand how money grows. And this also is why it's so vitally important that you save money early for retirement in your life, because the earlier you start saving, the more opportunity that money has to compound and grow. If we look at the PowerPoint slide here, we have two directions, and this curve's not a great one, or it's not a great diagram to explain it, but over time, this is how money grows. And as we see, when you're saving money and it's compounding, it grows exponentially, okay? And that means incrementally would be a diagram where this line was perfectly straight if we looked over large time frames. But again, because of the compounding effect of money, money grows exponentially because it has that compounding interest effect. So when we run calculations in finance, we have to account for this. And we have two ways of looking at it. We can look at the compounding effect in a forward manner, and we call that the future value of money. And then we can also look for it in the different direction, which is called the present value of money. Okay? And depending on the formula and what we're looking at trying to compute, you just try to look at the direction in which uh, it makes sense, and then you know whether or not you use present value or future value. And any good financial model or formula online calculator that we use needs to take that into account. So, present value is the value of a sum of money expected to be received in the future. Now, how I think of this is if I need $1 million for retirement, and I figured out that that's the amount I need to live comfortably after I retire until the day I die, then I would have to figure out how much money I need today. And it's a little like the formula for velocity is you need to figure out the different variables. One would be the amount of time until you retire. The next thing that you would want to look at is the principal amount you have. And the last thing is at what rate does it compound at? So if I'm trying to find that, I would like to know how much money I would need now, okay, or need beforehand to do that. So if I know I need $1 million, I would be looking at the formula in this direction, the direction of this arrow, in order to figure out how much do I need now in order to retire with $1 million. So I would use a present value formula. Now, if I looked at the same sort of example, but a little differently, is if I have $100,000 today and I have 30 years until I retire, and I know I can lock in an interest rate on a time deposit for 25 years, I would look at those variables and figure out at the end of the 25 years, how much will I have in the future? Again, because we have this compounding effect. Therefore, I'd use the future value. So if you think in terms of the arrow in this direction, what are you trying to find? Then you know what future value or present value formula we'd use. Now, in order to calculate that, we can use formulas and equations, write it out by hand. You can use a special calculator. Some of you, again, that have taken an accounting class maybe have seen it's called a TA82 something financial calculator. Texas Instruments uses it. Or, and I like to use this one when you're first learning the concept, we can use present value and future value tables. Okay? And what these tables are is if I know the principal amount of money I have, over here on the left, I can see how many years, so I can figure out the time factor of that, and then I can figure out an interest rate. So if I have $10,000 today and I can receive 2% interest on that from the bank, and I need to figure out how much will I have at the end of 10 years, I would multiply the principal, either, I don't remember now if I said $10,000, we'll go back to $10,000. I would multiply that with this table. So I have 2% I'm getting from the bank. I'm holding it in there for 10 years. All I have to do is multiply that principal amount of $10,000 times 1.21899, and I can figure out how much I would have at the end of that 10 years. So if we quickly did that, I would, just at the top of my head, I would have $12,189.90. Okay, if I had 10,000 at the beginning, I held it for 10 years in that bank savings account, I was receiving 2%, that's how much I would get. Then we have a present value table, and again, that looks at it in reverse. So the longer the term and the higher the rate, the lower the number. And you'll see that these all go in a decreasing direction. And to me, that's the best way of learning the concept of time value on money. Now, here is a midterm and final exam test question. And the reason I highlight so much importance to this is in almost all of finance, we apply this concept of the time value of money. In fact, we can't really run an accurate formula without taking it into consideration because in the world of finance, we don't have simple interest, we have compound interest. So, that being said, if you were to open up a book, one of these books maybe I have on the bookshelf back here, that is a financial textbook, in those or financial book, they're not going to talk about present value or future value rates. Okay, these rates up here, they're not going to use that term. In those books, instead, they're going to call these interest rates the growth rate. So future value is no longer called the future value, it's called growth rate. Present value in these same formulas then is called the discount rate. You won't see in those books anything about present value. Instead, you're going to see the discount rate. So if you ever see that, what we're talking about is a present value table. So if you think about the discount rate, think about this, and that'll help you out so you don't get confused about those terms. So again, on your final exam and on your midterm, a question's going to be asked or presented, what's the present value? And then there's going to be the equal sign and the discount rate. Okay, so present value is now going to be called the discount rate, and future value is going to be called the growth rate. And again, we're saying that so if you read any text or information on finance, that you'll know when you hear growth rate, we're just talking about the future value interest rate that you see up here. All right, now we have some different exercises we can apply. Let me talk about the Texas Instrument calculator again. Only in the world of academia and testing are those calculators ever used. In application, you almost have to use Microsoft Excel, and there's a few other types of software out there that you can use for financial calculations. But the reality is, we can't. You need more information, and it's far easier just to make a financial model with Microsoft Excel because often the calculations, we're going to be using both the future value and the present value simultaneously in these formulas. So again, it's a lot easier just to use Microsoft Excel or use an online calculator. And the important thing to remember is in all of those online formulas or online calculators, they almost always apply the time value of money. If they don't apply the time value of money, you wouldn't want to use the model because the data or the information you're going to get out of that is irrelevant. So we always use the time value of money. And again, we almost always use it simultaneously in any formula. So in order to find an amount you need for retirement and getting a game plan of, okay, how much do I need to set aside each month, each year to get that amount, you're both calculating the future value and you're calculating the present value. And what we'll see here real quickly with a couple of basic exercises is it's not telling you a lot of information. So I kind of nag on textbook the editors and folks that work in finance when they give these examples. It's almost easier to understand a financial model on the internet or a financial model in a classroom setting as opposed to breaking it down into chunks. Because when you start doing that, you realize, oh, this information's not, it doesn't tell you anything. One of the examples, a present value table, is Susan determined that she needed $1,000 to take a vacation in 2 years. How much will she need today if she can invest in a certificate of deposit earning 15% for a 2-year term? So if we looked back at the future value, she needs $1,000. Whoop, needs $1,000. You would play with the math until you found out, and we don't have a 15% up here, but you look at 2 years at 15%, you'd get a number somewhere between this 12 and this 20. and you'd add in a couple of different numbers until you could figure that out. Or excuse me, we wouldn't use the growth rate, we would use the present value. So we'd multiply $1,000 2 years at 15% and figure out how much we need today. So instead of 15%, let's say 20%, 2 years, we multiplied this $1,000 times this, and what we would need is $694.40, because 1,000 times this variable here equals that. That's how much we would need today if we could earn 20% for 2 years. Now, a future value example, John found a website that said for him to retire and earn the same salary he currently makes, he's going to need to save about $1 million. John wants to retire by age 55 and is currently 45, so we know it's about 10 years. He currently has all his money, $600,000, in a bank savings account that earns 6%. If the bank continues to pay the same 6% for all 10 years, does John need to save any more money? So we would multiply or find 6%, 10 years on the future value table. 6% at 10 years. So we would multiply 1.79085 times $600,000. And the answer would be no, John doesn't need to save any more money, because at 6% for 10 years, he would have more than $1 million when we multiply that future value variable times $600,000. I'll go ahead and pull up a regular calculator here just to prove that. So again, 6% at 10 years, we'd multiply 600,000 times 1.79085, and we get $1,074,510. That's more than $1 million. So again, what we're saying is John doesn't need to save any more money. All right. Now, for the purposes of this class, you're never going to really have to worry about this. I will give you online calculators that we'll use, and it actually simplifies life for us and for you, where we're not sort of using crazy story problems and you're going to have to monkey with any of that. We'll just give you the calculator that'll give you the answer and make life easy for you. Again, the best way I think to learn this information is just understanding and using those future value and present value tables. After that, internet calculators will, or those you can find online, will take it into account. Now, one of the things you need to note, again, about the world of finance and internet calculators and running these calculations is when using those to determine the amount, is it's not critical to determine exact amounts. People that are sort of new to finance are always, especially like on a test, they'll try to do a formula. And by the way, you won't have any formulas on your midterm or your final exam, but they'll try to run a number and figure out maybe an interest rate or a growth rate, or they'll try to run the numbers. And I remember taking a class when I was in grad school, and this one young lady was running the formula, and the answer to the problem was like 13%, but she got 13.095%. And the instructor still counted it right, but she kind of got upset and said, well, why isn't it exactly 13.095? And I want the right answer. Well, the reality is in finance, you're almost always forecasting, and you're just trying to get in the ballpark. You don't need to be exact. Now, if we look at the world of accounting and bean counting, if you will, in those environments, you do need to be exact because you're keeping record of something. But in the world of finance, we're usually forecasting or trying to determine something. you're never going to be exact. And your goal is to get in the ballpark, it's to be in the general area so you have an idea of how to plan for the future. Okay, so something to remember. Accounting is exact, finance is very often not exact, and later on you're going to see some real interesting numbers and some fun stuff and realize, okay, this why it's just a ballpark number we're trying to figure out. We're good there. Couple other things that we need to talk about is the nominal versus real rate. This kind of goes back to that simple interest versus compounded interest and taking that into account. Somebody usually asks, well, what if we take into account inflation? What's the impact of that? And inflation is one of those concepts that we need to apply because you can think you're very wealthy or that you're doing well saving money, but if you're not earning enough interest to factor in the compounding effect of inflation on the time value of money, you start having a problem. So if you ever hear the term the nominal rate or the real rate in finance or accounting or anything business, the nominal rate is the rate that doesn't take into account inflation. We don't look at inflation when you hear the nominal rate. The real rate is the rate that we look at once we account for inflation, and we use something called the Fisher equation to figure that out. And it gets pretty complex. We're not going to worry about it because, again, we're not trying to find exact numbers. A far easier way to figure that out is just to subtract by either 2 or 3% or somewhere in to factor in for inflation. So, for example, if I'm earning a 10% rate of return, and I know historical inflation has been about 3%, then we just take 10 minus 3 and find that the real rate or rate of return on that would be closer to 7%. Okay, because we need to factor in inflation. Most of the calculations and stuff that we do in here are already going to take this into account, so you aren't going to have to worry about this. But these are words that you may see in the world of account or in the world of finance, and just to know the difference between the two. Real factors in inflation and subtracts it from the rate of return. Nominal is just that rate of return without adjusting for it. All right. A couple other terms that are very specific to the world of personal finance, and again, this is going to be a test question, is annual percentage yield, or APY, and annual percentage rate. Now, in the world of consumer banking, we use these terms. APY we use for deposit accounts. So what ended up happening a number of years ago is if you were to shop at different banks to deposit your money and you wanted one that, for let's say for a savings account, paid the highest interest rate, when you walk into the bank, they would hand over what's called a quote sheet to you and say, we're going to pay you 2%. The problem with that is there maybe were a lot of other numbers that were factored in or were not factored into that. Maybe there was a $10 monthly fee for having that savings account if you didn't agree to keep $2,000 in there, minimum balance requirement. So the Office of the Comptroller of the Currency and the Federal Deposit Insurance Corporation said to banks, look, you need to factor in everything into those rates. And if you're just quoting the basic rate and not factoring these other things, the consumer can't compare apples to apples and oranges to oranges. Because they can go to one bank and you guys are factoring in this, and you go to a bank down the street and they're not factoring in this information. The sort of real rate of return that they were receiving is different. And the same happened with loans. If I'm trying to find the lowest rate to pay on a consumer loan, and I'm going into one bank, Bank A, and they quote me at 6%, but by the time they charge me fees, maintenance fees, closing costs, everything else, the equivalent was 8%, but I go with them because they only charge 6%. Then I go down the street and I see, well, they're charging 7.5%, and they're factoring everything, I, as a consumer, had no way of taking that into account. So, what the Office of the Comptroller of the Currency, who's a bank regulator in the United States, and the Federal Deposit Insurance Corporation, another uh, regulator of commercial banking, they said, here's what we're going to do. And they gave every bank a formula of exactly what they're going to take into account. So when you go to shopping for deposit accounts and you're looking for the annual percentage yield, that yield will tell you the actual rate of return that you'll receive on that deposit account. Again, that's annual percentage yield is for deposit accounts. And that, when you're looking at shopping at banks, is what you want to look at. Then we have the annual percentage rate, which is the rate that you want to look at when being quoted by banks for loans, because that annual percentage rate takes into account all the other hidden costs and everything else. But consumers sometimes just look at the quoted rate and not the annual percentage yield, or APY, or annual percentage rate for loans, the APR. Now, one more time, I'm going to say this is the APY is used to compare deposit accounts at a bank. The APR is used to quote loan rates. Okay, so you'll need to know that. And again, those are those questions, and these are the exact questions you're going to see on the midterm and final. We can use present value and future value for many calculations, but most often we use them to determine what? Present value will equal the discount rate. Future value equals the growth rate. And that's the correct answer. What is APR and APY, and why should you use them and not the quoted rate for a bank? APR is used to compare loans from bank to bank, and APY is used to compare deposits at bank to bank. And that concludes our section on the time value of money. Thank you, and we'll see you later.